Okay, here we are on the last stop on the Grand Canyon South Rim field trip, where I have inadvertently saved the very best for last. We're going to get some excellent looks at the Proterozoic basement rocks all the way down to the river, the overlying Great Unconformity, and the Paleozoic sequence on top, and some recent geologic history of folded and faulted rocks. So we're going to stop at Hopi, Mohave, Abyss, and Pima viewpoints. So where are they? Let's zoom in on an area approximately here. So here we are. Here's the main road in and out of the Grand Canyon Visitor Center area. Hopi Point is located here. Mohave Point is here. Abyss is approximately there. And Pima Point is here. And the views that we're going to be seeing here are to the north and generally to the northwest. Take a quick look at the geology. Again, here's Hopi Point, here's Mohave Point, here's the Abyss, and here's Pima Points, and we're going to be looking more or less in this direction. And what we're going to be seeing is mostly the Vishnu basement rocks, the Grand Canyon Metamorphic Suite, the overlying Great Unconformity, and then the entire Paleozoic sequence on top. There are no supergroup rocks in this area, at least none that we can see. So in terms of the map on the left, what we see on the bottom of the canyon down here is the Metamorphic Suite, the Vishnu basement rocks, and from this sort of pink color all the way up to the lightest blues, these represent the Paleozoic sequence. All right, here we are at Hopi Point. Offers a really expansive view of where the Colorado River flows more or less to the west and then takes a turn off to the northwest. You can see the river down there. But what I want to focus your attention here at Hopi Point is, let's zoom in on a box roughly there, and a very up close and personal look at the Paleozoic sequence. Okay, we can see the Vishnu basement rocks here, the Great Unconformity, which I've labeled, but the point of this stop is to focus in on the Paleozoic rocks, and so I've labeled them all. In the links below, you'll find this and another image that isn't annotated in extremely high resolution that allows you to zoom in and see these layers quite close. And so I've labeled them, in order to see each layer, but what I encourage you to do is to try to find the corresponding rocks somewhere else in the image. For example, here's the Supai group here, and we can go off to the left here and try to find it again. So here's the bottom of the Supai group. And here it is here, right? And here's the Coconino sandstone here. Let's try to find it elsewhere in the image. Here it is, this white layer here, and off in the distance there. All right, let's move around the corner to Mohave Point. Mohave Point offers a similar wonderful view of the western part of the canyon. And there's two things I want to point out here, and let's zoom in on this area. Here we're going to focus on underlying Proterozoic basement rocks. The metamorphic and igneous rocks here. And so I've provided a very, very high resolution image here where you can zoom in and see the foliation of the metamorphic rock, which is near vertical. You also can take an up close and personal look at some of the intrusions, these kind of pink granitic igneous intrusions that intruded the metamorphic rock as it was being metamorphosed. Let's go back to the panorama. I'm also provide a high resolution zoom in on this area, which provides a nice look of similar geologic features of the Vishnu basement rocks, the Great Unconformity, and the overlying Paleozoic sequence. In a moment, we're going to be zooming in on this area at Pima Point, and so I just want to point out some features you might be familiar with. That feature is Point Sublime. If you went on the North Rim field trip, you have been there before. And we're also going to be looking at the fact and understanding why we have this sort of dip here, why these rocks are folded off to our right, and in terms of the name, that area is called the Mohave Saddle. We'll come back to that when we come to Pima Points, or to Pima Viewpoint. Let's take a quick stop at the Abyss. It offers a very similar view to both Mohave and Pima Points, but what I want to point out is just how steep the western part of the canyon is here. So at the Abyss viewpoint, if you wander off to the rocks a little bit to the left of the viewpoint, you can come to what is a nearly vertical 1,000 feet plus drop. it is quite remarkable to stand there and look straight down into the abyss. And finally, over to Pima Points, offers another really great panorama view. You can see the river in a few places here and here. But what I'm going to focus your eye in and talk a bit about here is this area. So here we are. This is Point Sublime, and this, as I mentioned, is the Mohave Saddle. What we've got here is evidence of relatively recent 70 to 40 million year or so deformation of these layers by faulting. So between about 70 to 40 million years ago, this area was undergoing compression, and so rocks were deformed via reverse faults and folds. And so what we have running through this area, as I've kind of sketched here, is the Mohave Fault, and it kind of runs beneath these rocks towards us. And so the rocks on the left of this fault during the compression were moved upwards relative to those on the right, causing this gentle folding here. This is the part of the Crazy Jug monocline, which we saw from Point Sublime also, and you can see from other points in the South Rim. Off in the distance, we also can see evidence of this faulting activity, where we have the layers on the left of the Mohave Saddle, such as the Coconino Sandstone. Here's the top of it. It's bent down, folded down off to our right, and it's relatively flat over on this side of the fault. So the Mohave Fault was active as a reverse fault. The rocks on the left side were pushed up from roughly 70 to 40 million years ago. But this, like many other faults in the Grand Canyon, was reactivated as a normal fault more recently, 15 million years ago or so to present, and the rocks on the left have moved down relative to those on the right. So in terms of overall displacement, they're kind of back to where they started, but the evidence of the faulting is still there. So as during compression, as the rocks on the left are moved up, they kind of got folded and bent as the friction along that fault zone prevented the rocks in the vicinity of the fault from moving as far as those in the distance. So that explains this kind of gentle bending off to our right. All right, go take a look at the images for yourself, and thanks for listening.